Hello everyone, hope you are doing well. In this video, I will explain about most important Springboard concept that is called rate limiting. So for this, I am using Bucket4J API. So initially, this is developed by GitHub. So integrate rate limiter in Springboard with Bucket4J API. What is Bucket4J API? It is meant for the rate limiting. So what is rate limiting? Control requests per given time period. That means, so assume you have a Spring Boot application. In that Spring Boot application, you are developer for APIs or four endpoints or in controller four methods. So you want to respect certain time period. Assume like a every 30 seconds, every 30 seconds. So this particular API can accept only five requests. So for this purpose, use rate limiting. In Bucket4J, most famous use case is pair IP rate limiting. So, if you want to restrict some particular user to access, if you want to restrict particular API, so certain time period, like suppose one API will be there, assume like a fetch data API is there. This API every 30 seconds, particular user only five times can access. If that user try to access more than five times, it will say like too many requests like that, some error kind of, some too many requests. Wait some time like that. In ATMs we will see mostly like uh service is not available. That means like once after ATM cash cash is over, so if certain users accessed, after that it will say like service unavailable like that, right? So that is concept like a circuit breaker. So now I am explaining the rate limiter. It is nothing but particular user few APIs is there. How many times can access that API? So we can restrict suppose 30 seconds. I am setting the 30 seconds and five requests. So like one user that particular API can access within the 30 seconds five times only. If try to access more than five times, it will say too many requests like that. Some some page we can display. So I am using for this Bucket4J API Java 17 Spring Boot 3.5.4 version. So I will post write some bullet points about Bucket4J API. So let's get started. So I am mentioning like a step one. So Bucket4J API. This API used for rate limiting, rate limiter, rate limiter, right? So now in step one, theory points are most important. First one, it is it is used for rate limiting. Rate limiting, it is used for rate limiting. What is rate limiting? So controlling controlling how many requests or operations can be performed can be performed in a given time period. In a given time period. So it is most important. It is used for rate limiting. Rate limiting. What is rate limiting? Controlling how many requests or operations can be performed in a given time period. This is the first point. Second point, this bucket for JAPA works token bucket algorithm. Based on the based on the token bucket bucket algorithm. Based on the token bucket algorithm. Third point, it is a thread safe and can be used in high concurrent environments. Thread safe It is a thread shape and can be used in high concurrent high concurrent environments. Environments. Port point supports both in memory and distributed scenarios. Supports both in memory and distributed scenarios. Scenarios. Fifth point. Few rate limiter APIs are, so one is the Bucket4J, second one Resilience 4J, so Resilience 4J, Resilience Resilience 4J, third one Spring Cloud, Spring Spring Cloud rate limiter, rate limiter. These are the three APIs for rate limiting. So I will explain this Bucket4J in this video. Resilience 4J also used for the circuit breaker concept. If any API is failing continuously, then instead of calling actual method, so we are bypassing the request to the some dummy method like service is not available like that. So Spring Cloud rate limiter, this mostly we can in application or properties where key value pairs we will mention for this Spring Cloud rate limiter. So 6 point in this video I will explain based on this use case pair IP rate limiting. So pair IP rate limiting pair IP rate limiting. So use case use case is limit limit how many requests each IP address can make. So example a user tries a user tries to send 1,000 requests in in 1 minute in 1 minute from assume it is a local IP like 192.168.1.5 1.5. So here so you limit it to 100 requests per minute per minute per minute. So this is the use case I will discuss in this video. Pair IP rate limiting use case limit how many requests each IP address can make. Example, a user try to send 1,000 requests in 1 minute from this IP. So so I will limit here. So you will limit it to 100 requests per per minute per minute. So suppose I will change like a 5 requests 30 seconds. Suppose 7 requests 30 seconds. 5. So pair IP rate limiting. Use case limit how many requests each IP address can make particular time. A user try to send 7 requests in 30 seconds from this particular IP. So, like you will limit it to 5 requests per 30 seconds, per 30 seconds based on IP. IP. So, more than 5 requests, 5 requests, 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 more than 5 requests. So, more than 5 requests within given given time period. So it will like we can say like too many requests, some message, too many requests like that. So this is we are discussing. I will repeat one more time this use case, pair IP rate limiting. This is our use case. Use case limit how many requests can how many requests each IP address can make. The use case limit how many requests each IP address can make. Example, a user try to send 7 requests in 30 seconds from this particular IP. You will limit it to 5 requests per 30 seconds based on the IP. More than 5 requests within the given time period. So it will throw suppose so it will throw too many requests. Otherwise it will redirect to too many requests. Better to it will say too many requests. Once this is so within the 30 seconds more than 5 requests are user can send, then it will say too many requests. So I will also add another use case, but this use case I will discuss in next video. Pair user rate limiting. Pair user rate limiting. So it is the another use case. Use case. So limit requests for each authenticated authenticated user authenticated user based on based on user ID or user ID or token based on user ID or token. Example user, I am adding my name Shankar, can only make make suppose 5 APA calls, no matter what device, no matter what device IP they use. This is another use case. So pair user rate limiting. Pair user rate limiting. Use case. Use case limit requests for each authenticated user based on user ID or token. Example, user Shankar can only make 5 API calls no matter what device or IP they use. So this is the step one. Still 3 points are done. So let's develop one POC project. So step two. So let's create a Spring Boot project. New Spring Starter project. So let's say like rate limiter. rate rate limiter bucket4j demo. Rate limiter bucket4j demo. So package name com.fst, group name and package name must be same, Java version 17. So build type Maven, packaging where. So next, so I am using here Spring Boot version 3.5.4, 3.5.4. So back Java version 17. So I need to add so verb. If you are not found, this is the frequently used. If you are not found, you can search verb like this. It will appear. Otherwise, you can search spring verb like this. After the spring verb, so spring data JPA Lombok. So we need to add spring verb, spring starter verb, data JPA Lombok, MySQL driver. So GitHub in GitHub Bucket4J dependency. This is not available. It is not related to Spring. We need to get it from the ambient repository. Next, finish. Meanwhile, open Chrome. Open Chrome. Go to ambient repository. Ambient repository. So ambient repository Bucket4J. Bucket4J. Search. Click on post com.github.this. So select the version. This version you can select, copy. Let's check this. Yeah, this project is created, right? So form.xml, scroll down. So we need to mention like bucket 4j, bucket4j API. It is a command. So add here, select Control Shift F for the format, Control S. So once Control S is done, right click on the project, Maven, update project, um, click on checkbox, force update of snapshot and releases. Okay, so it will update the so these libraries it will be updated. Maven dependencies it will be updated. So once it is done, so we need to add application dot properties. So first let's copy these dependencies. So step two, I am mentioning like a dependencies. Dependencies. So step three. Step three is the application dot properties. So in step three, I'm adding application dot properties. Go to the SRC main Java, SRC main Java, SRC main resources, right? In the resources application dot properties. So compared to application dot properties, YAML files will be speed. So if you want to change, you can also change application dot OML. So OML little bit structure will be changed. It will be eliminate duplicates, duplicate levels. So now spring dot spring dot data source spring dot data source dot spring dot data source dot URL. This is the post one. So for this JDBC colon JDBC colon MySQL colon double slash localhost. I am using localhost, so I am mentioning localhost. If you are using AWS, then you need to enter AWS some RMA something. You need to replace just replace this one sufficient. So colon 3306 schema database. As of now, I have not created any schema database, so let's create. So open the workbench. Let's open the workbench. Let's create testDB. So create the testDB. So wait until it will open. So local instance continue. See these are the schemas. Schemas are databases are there. So let's create new one, new schema like testDB. TestDB apply. So it is saying already is there testDB. So let's delete this testDB. Drop schema. So we open the MySQL. TestDB schema is already there. So I dropped. Now I will add new one. Like again I will add testDB only. So I am mentioning here same. This is the schema database name. So MySQL workbench. Meanwhile, enter these properties. Next, spring dot data source dot username. Spring dot data source dot spring dot data source dot username. Username is a root. So 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 username is a root. See, so this is the local instance. So continue anyway. So these are the schemas are there. I want to drop testDB. Drop. It is dropped, right? So add schema testDB. Apply. Apply. Finish. So testDB added. Same I am here. Mention. This is the schema or database name. This is the database username. Next. So password. Password also root. So password root. Driver class name is optional, but I'm adding. So string dot data source dot driver class name. It will give options. See select com dot mysql dot cj dot jdbc dot driver. So after that, so auto update JPA DDL auto. We need to add auto. It will create tables automatically when our Spring Boot application is startup by using this. Spring dot JPA dot Hibernate DDL auto. It will give options select update to show the SQL commands in Conjure. For that add Spring dot JPA dot show SQL. It is a boolean, so true. These are I am added in application dot properties. Control C, Control V. Step 4. Let's develop the entity class or model class. So I'm saving this file in downloads. Go to the code. So let's add the model. So com.fst, right click, new class, package name, like model product. So let's add four fields here, like name, description, private, post, primary key for first, long ID, private, string name. Let's add five, private, string, description, private, product price rate, double price, private. So private, integer, integer, quantity. So these are the files. Let's add the annotations, like so entity. So entity, see, specifies that the class is an entity. So so specifies that class is an entity. That means it is a one database table. That table name, if you want to, by default product is a table name. If you want to change table, one annotation is there, table in that one attribute name. So add the product for setter getters. You can add setter, getter, toString. So I am not adding any all R constructor, no R constructor. So these are the fields. So primary key, every table must one primary key ID. So I am mentioning like this ID auto generated. So other item generate. So generate value here, generator type, generate value, attribute is the strategy. In the strategy, generate generation type dot. So identity. Identity is recommended for the MySQL. So this is the done. Let's create one repo. So as of now, model is done. Let's create the repo. New class, repo, product, repo, product repo. So it is a interface, not class. So right click, new interface, product repo, extends JPA. So extend JPA repository, JPA repository, finish, okay, finish. So type, it is a product rate, product ID is a long. It is a done, close. So this must move to repo folder, move to repo, import. So model is done, repo is done. So let's say add the filter. So now filter. So class filter. So like filter name like IP rate limiter filter, IP IP rate limiter, IP rate limiter filter. So extends one per once per request filter. So once per request filter, it is not showing. So it is a super class, I think so. Once per request filter, it is a class. Finish. First annotate it at component. So add some comment here. So global filter that applies global filter that applies rate limiting where client IP using Bucket4J. So now at component added rate. Now what we need to do? This is for all APIs. This rate limiter will apply on all APIs. I will also show next video how to apply rate limiter for particular API. So first we need to find the IP. So this is the request rate. We need to first find the IP request dot. So get remote address. Get get remote address. So it is a client IP address. It is a client IP. It is a client IP address. Let's see. It is a which type? It is a string. So string IP equal to. So let's add logger as well as 4J. Now let's print this IP. Log.info log.info. So now about IP address, comma IP. So IP address we are printing, right? So after that we need to so check like so buckets dot compute if absent. So we need to check this IP is. So we need to check. So we need to check IP is already exist or not. For that, so let's take one class level variable like private final concurrent map. So key is the string, value is the bucket. So buckets equal to new concurrent. So concurrent as map concurrent as map. One command here, import the bucket. So For import, Control Shift O, Control Z R. So cursor on this name, it will give suggestions as well. It will give suggestions. So these are so many are there. So bucket io.github.bucket4j.bucket. So this is the buckets, right? Copy these buckets. So it is a map, concurrent map, right? Concurrent as map. That safety will provide, right? Buckets dot. So buckets dot compute. If option it is checking, it is already present or not. IP. So bucket, we need to create bucket, right? For that, so we need to create bucket right here. For that, let's add another method. So private bucket, new bucket, new bucket here, string IP. So I am using method reference. I will use method reference here. This is nothing but current class, control as new bucket. So comma here. So one bandwidth will be there. Bandwidth the classic. Here we need to mention how many requests allowed. So bandwidth. So bandwidth. See what is telling? Bandwidth. Use classic long capacity. Capacity. My API is there 30 seconds. 5 requests only capacity. So let's check capacity refill. Once this is time period is 30 seconds is completed, then again 5 requests I'm saying refill. See, the bandwidth is the key building block for bucket. It consists of the capacity and refill where capacity depends the maximum count of tokens which can be held by bucket. Refill depends the speed in which tokens are regenerated in bucket. So now we need to, this is the capacity, this is the refill. So refill, IO dot bucket, refill dot, so refill dot, see create the refill that does not refill the bucket. Greedily manager it will try to add the tokens to the bucket as soon as possible, for example. So after that, greedily did the long tokens. So was add, I need refill after that duration. I said 30 seconds, right? For duration, 30 seconds, right? Duration dot half seconds. Duration dot half seconds. So I am mentioning like 30 seconds. After that, return. So Bucket4J. In Bucket4J, one class is a builder. In Bucket4J, one method is a builder. It is a static method. So it is a static method. Next dot add limit. Add limit. So let's store in this in limit. Limit. This limit we need to add here. Dot build. So this is the done. Let's add a command. Let's add a command here. So why we created this? So create a new rate limiting bucket for a given IP. Create a new rate limiting. Create a new rate limiting bucket for a given IP, given IP. So next allows five five requests per 30 seconds. Five requests per 30 seconds. It will applicable for the all endpoints, all APIs. If you want to restrict, then here, so request dot get get remote some path will be there. Get remote address will be IP address. So here get request URL. See, return the URL path of the request URL. It will string. Suppose string path. We need to compare this path. We need to from the constant. We need to take one path. Both paths we need to compare. Both are matching. So then we need to execute this logic. We need to execute this logic for particular endpoints. This rate limiting will be applied. If you want to apply rate limiting for the particular endpoint, we need to use this. This I will explain in next video. So it is done, right? So now we need to consume token, right? This is bucket is done. Let's bucket equal to, so if condition, if bucket dot, if bucket dot try consume, like each time saying consume one, bucket dot try consume one. So here filter chain will be there, right? Filter chain dot to filter. We need to add request response. This is the done. Else response dot set status. So like try consume one. So consume one at a time. One request will be consumed for particular IP, right? Like that. If like 30 seconds more than five requests are raised called, then it will be else block will be called more than, so five requests will be user will be sent, then else block will be called. So HTTP status, so HTTP status dot too many requests, so too many requests dot value, it is expecting the integer value, so dot value. Next response dot get writer dot write. So string will be there, right? So like if within the 30 seconds more than five requests are sent by the user, I'm saying, so too many requests, too many requests too many requests from too many requests from, so IP, then plus IP. So if within the 30-second more than five requests are sent by the user, I'm saying too many requests from IP address. I'm printing IP address. So So it is done. Let's develop the controller. So let's develop the controller. I will take like product controller, right click new class, product controller, finish. I will annotate with at rest controller, at request mapping. In request mapping, I will mention like product product. So let's inject so repository to the here private final product product repo product repo. So here required R constructor. So instead of using auto wait, I am using final and require R constructor. So I will develop two endpoints. One is the saving, one is the save, and one is the all get all. So post mapping and get mapping. So first I will develop public response entity, public response entity T type, product type. So save, save, save product. So here request body, yet, yet request body, product, product, product. So maximize. So import. So now product repo is there, right? Product repo dot. So save, save. This is the product. It will return the product, product response, right? Return new response entity, return new response entity. So product response, comma, HTTP status dot created, dot created. So annotate post mapping, post mapping, post mapping, save, save. This is the save for save endpoint. Let's add the another endpoint for the get all public response entity. So all means it will like a list of product. So list of product, get all products, no inputs, no parameters. So product repo dot find all. We need to enter the list of products. So list of products equal to control shift O for the import. So same return, copy this, paste here. Now list of products, status code will be okay. So I will add some logger as well as LF4J. So let's add the logger. Suppose I will add here log.info. What I'm seeing here. So product ID. So product ID. So now product dot product response dot get id. Here also log dot import list of products. So here list of products product size. I want to print the size. So for that, so this is the list reference variable dot size. So list reference variable dot size. Here comma will be there. Control S. So all files are done. Let's run this application and let's insert two records through Postman. Let's run. Let's run this post. See, let's see. Let's move to controller package. Move to controller. See, model repo filter controller. This is a starter class. Right click, run as Spring Boot app. Meanwhile, open the Postman. So we will insert two records. If any database application dot properties files is here, application will be here itself failed. The table will be created. Right? On startup table will be created. So now let's check the path. Go to the controller, product controller, product product class save. Right? This is the post product class save. This is the body. So like when it feels right. ID auto generated, so no worries. This remaining name description, size, quantity. So name, we need name description, price, price, quantity, price, quantity. Suppose quantity will be one, price will be 1000, description. Suppose it will be string, electronics electronics products, comma will be there, name. Suppose I will mention like my name, Shankar, comma will be there. That's is the send. So it's saying not found. So not found. Let's check the path. If there any mistake, let's go to the controller slash product slash save. HTTP colon double slash localhost 8080 slash product slash save. Product spelling wrong. Let's change product control as. Let's stop the server. Let's rerun the server. Right click run as Spring Boot application. So wait until Spring Boot application up and running. So now send. See created. So let's check in database. We are inserted one record. This is the schema. Replace product table will be created. So one record will be inserted. Let's add another record. Suppose Ravi electronic products only. This is the 2000 quantity 2. This is the done, right? So next API is the product slash. So let's check next API. So we are not mentioning anything here. Yet get mapping slash r. Let's stop the server. Let's rerun. Run a Spring Boot application. So it is the R. So slash R send. See, this is the get mapping, right? Send. It will retro two objects. Second time, third time, fourth time, fifth time, sixth time. See, too many requests from IP. So now let's try after refresh. Refreshing after 5 seconds, it will be refreshed. So getting. See, let's go to the filter logic. Filter logic. So 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 5 requests will be allowed. Refill every 5 seconds. So refill every 5 seconds within the within the 30 seconds. 5 requests only allowed. If more than 5 requests try to hit, then wait for the 5 seconds. After 5 seconds only, it will be refill. It will give chance to again send the another 5 requests. Same this get endpoint I will throw like Chrome browser as well. I will show. So this is the first time, second time, third time, fourth time, fifth time, sixth time. See, too many requests from IP. So it is rate limiting, perfectly working. Next try, it is again working. 2, 3, 4. See, too many requests from IP. So in this video, we are successfully understand. So in this video, we are successfully understand integrate rate limiting in Spring Boot with Bucket4J. So Bucket4J is the API rate limiting. So it will by using Bucket4J API, we can achieve rate limiting. What is rate limiting? Control request per given time period. In this video, we are using use case like pair IP rate limiting. Thank you for watching. For more videos, please subscribe to this YouTube channel.